Hello there, it's Jay here from Jay's Vintage Junk, and today back on with the Toshiba T1000. I've just been messing about with some software on it. This is a game called Applejack that I downloaded earlier and just thought I'd see if we can get it to run on here. And it basically shows you how good CGA emulation you get on this LCD screen. I mean, like I said, this is a CGA game. And unfortunately I can't quite figure out how to play it, but at least it shows you it is just about playable on a little LCD screen like this. Only thing is, obviously, when you're actually moving your characters, they're just one big blur. They're okay when they're stopped. The problem I've got with this game is I can move left or right, but I can't figure out what the up or down keys are yet. I'll have to have a look at the documentation on it. But yeah, what I thought I'd do in this video is we'd have a look at this keyboard. 'Cause, I mean, the keyboard does basically work on it. Let's do a quick Control-Alt-Delete so we can get to the DOS prompt. Oh, I've left the disk in. No. Oh no, there we go. It's up. So it seems to be working absolutely fine, the computer. The A key there seems to be the only real major sticky issue. It does work, as you can see, but you have to press it fairly firmly to get the A key to actually function. I've tested every other key, I think. I did go around them. Yeah, and they're all fine. It's just that A key seems to be just a little bit on the... yeah, no, it is a little bit on the iffy side, that A key. I mean, if the keyboard's completely sealed, yeah, it's livable with. I don't really bother trying to break it open if it got any worse or any other keys to actually stop working. But like I said, everything else is absolutely fine on there. It's just that A key's a little bit on the sticky side, on a little bit on the iffy side. So I thought what we'd do is before we seal this thing back up, is we'd go in it one last time and we will remove the keyboard and see if we can do something about that. And just disconnect the monitor and get the monitor out of the way. Come on, off you come. There we go. So we'll get the monitor out of the way and we will disconnect the keyboard. And found a few interesting I've been doing some research on this computer, and the more I play with it, the more I like it. It could be a chance that I can actually upgrade the version of DOS this thing boots up into. Basically what we've got here is, if you let me see if I can zoom you in so you can see a little bit better. Whoop. Yeah, there we go. Right, this chip we've got here with the Toshiba chip with the sticker over it, that's our BIOS, and that's just a standard like XT class BIOS. This chip next to it's the interesting chip, because that is actually your operating system. That is MS-DOS 2.11 on that chip there. And someone's actually read that chip out with an EEPROM programmer, and it's basically that's a mask ROM, but it is just a standard pinout of I think it's a 27C40 or something like that. 256K EEPROM is pin compatible with it. And a chap's wrote a little piece of software which will basically allow you to take, say, the DOS image for something, I think up to MS-DOS 5 I think you can do it with, and convert it into a ROM image, then burn it to an EEPROM and replace that, and actually upgrade the version of MS-DOS that actually boots from ROM from version 2.11 to, say, I think the maximum you can do it with is version 5. So that's something I'm going to look at in the future. Obviously not now. I want the computer all fully up and running first, but that seems like a really cool thing you can do. So it looks like I may be able to upgrade the operating system, still have it booting from a ROM chip, but actually have a much newer, later version of MS-DOS in there. So like I said, that's something I certainly will look at later in the future. But anyway, like I said, today's video is about having a quick look at this keyboard and see what we can do with this keyboard. So let's get the keyboard out of here, and then we can get the actual computer out of the way. I was also reading an article, believe it or not, there's I think he's in America, some chap. He has a company that has equipment all around the world. I'm not sure what the equipment's to do with, but it's solar powered monitoring equipment, whatever it is. And it was installed in the late 1980s. And the computers which actually monitor, basically do all the monitoring, are these Toshiba T1000s. And 30 years later, they're all still running. It says there's a couple of dozen of them around the world working with these monitoring stations. Like I said, the computers are 30 years old and they're still going. They're still actually up and running. I think it's absolutely unbelievable, that. Right, let's. I want to be careful here because I don't want to damage this this connector. I think if we remember correctly, we pull it up. It's like the more modern. It's just like a older version of the more modern connectors. Anyway, you pull it up to. That's actually up, I think. There we go. Right, so we've got the keyboard out. Let's get the computer out of the way. So I think that's absolutely unbelievable that there's still these actually out there doing what they did. You said apparently all they do is change the NiCad packs every few years. But I suppose if all you're doing is some basic monitoring and your software runs on MS-DOS, why would you need to replace it? I mean, if it's still working after 30 years, leave it working until the equipment's no longer needed. Right, it looks like it's fairly easy to get in here. Basically, we've got a load of screws. It's a bit like the old C64 keyboards by the look of it. So I think if we whip these screws out, we should be able to get in there and we can see, hopefully, a bit of isoprop and a bit of a clean, and it'll be good as new again. I am liking this old Toshiba stuff. It is really nicely built, I must admit. It is lovely the way this stuff's built. Very compact and what have you, but it's not too bad to service. It looks like it is designed, so you can literally repair everything. It's amazing with them I suppose because apparently they run 24/7 because they're monitoring computers. So I wonder with the fact that they run like that, they've not suffered the capacitor issues that mine and so many more of these have. Apparently it's a really, I've been doing a bit of research on this computer, and apparently the capacitor issues is a really common problem with them. And the other thing is everyone comments they're an absolute pain to do due to, as I found out, all the surface mount stuff around the legs. So I think my technique of removing the caps and then drilling through the solder probably was the best course of action in that situation. Obviously you just have to be super careful that your drill doesn't wander off and cause untold damage to the board. That reminds me, actually, I've not even unpacked it yet. I've got the box downstairs. I've ordered myself. It's not new; it's second hand, but another of my another PCB drill, very similar to this one, but it's actually got a stand. It's got the proper stand, which I bought this when I was about, I must have been about 11-year-old or something like that when I bought this, so 11 or 12. And it's worked all them years, and it's very similar to the one that I've bought, but like I say, it actually has the stand. I could never afford the stand when I bought that. I think that was about 15 quid or something like that, and I think the stands were about 35 quid. So I just learnt to use it handheld. But no, I'll do an unboxing video on that and show you what I've got. I didn't pay very much for it, so I was quite pleased to actually finally get one with a stand, which does mean it makes it a bit more precision when you do have to do very fine precision drilling. It's also much handier if you're drilling a circuit, if you've etched your own board, especially if you like doing IC sockets or something like that. It's not so bad if you're just doing through whole components. It doesn't matter if the legs are mil off or so. But when you're putting like an IC socket in, you've got to be dead accurate, or else you're never going to get the pins in. So that should certainly make things easier for that. Right, that's all the screws out. I'm just going to turn my heater down because my legs are burning. Right, let's see if... Oh, I've missed one. There's always one. That's the only thing I don't like about this keyboard, is it uses this horrible early type ribbon cable, like the printed ribbon cable, and these are notorious for breaking. The same thing's used in quite a few old 8-bit micros. Right, here we go, we're in. And it's very much like a calculator style keyboard, that. In fact, now where have we seen this type of keyboard before? I think we have to be very careful cleaning this. In fact, what I think I'm going to do is I'm just going to clean the A key, which is that key there. I don't want to risk disturbing this too much, and I can actually see as soon as I look on that there is some crud on that side on the A key. Excuse me. So I'm going to get a bit of isopropyl. I need to get some more isopropyl. I didn't put the lid back on, and I think it's evaporated. I'm going to get a little bit of isopropyl on there, and I'm just going to clean the contacts on the A key very, very gently. I'm not going to go near any of the others because all the others work fine. It was just this one that was a little bit on the iffy side. Try drying that off now. So there we go. I think that's it. And all the rest, they look absolutely fine. They don't look dirty or anything. It's just that looked like it had a little bit of crud on one end. There we go. If we have a look at that, this is spotless. There's nothing on it at all. There's not even any dust or dirt or anything, and it's got loads and loads of little surface mount transistors all over it. I think the three legs, I think the transistors, it's covered in them. And it's very, very thin board, that, but it's absolutely spotless. There's no crud or dirt or anything on any of these little contact points. It's really, really clean. Just give a very, very careful little dry brush over, just to... I'm not doing any more than that. I don't want to risk... and that's dry. I'm not using... There's no isopropyl or anything on that. I'm just using it dry, just to give them a very gentle little rub over. I'm not going to go mad on this keyboard. It really doesn't need it. I said the only thing was that A key. In fact, there's a bit of crud coming off them, so I think this is worth doing. The reason I don't want to use isopropyl is this is like little graphite pads, and if I'm not careful, you can remove them. I have used a pencil eraser actually before now to very, very gently clean them, but these aren't that dirty. They really aren't bad at all. I always get a text message when you're in the middle of something like this. We'll just get a new, oh, that side's not used, is it? So I'm not doing any more than just giving them a really gentle little clean over. You can see, I mean, I've got some crud off them, but I'm not going to go mad with it because it is actually really clean. There was just that bit of muck on that A key, so hopefully we'll put all this back together, and that should should have fixed that, and we can put this computer back together. Hopefully we've not made it worse by doing that. I don't think we will have. So I didn't want. If it was filthy in there, I might have risked perhaps being a little, or using something a little bit more abrasive. But it really wasn't bad at all. Well, you can tell that by the fact that the only key that was causing us any problems was that A key. Like I said, if it had been any more sealed than this, I wouldn't have even bothered going any further, at least until it started to be, you know, misbehave more, because it weren't as though the key wasn't working, it's just it needed a bit of a firmer press down than all the other keys, which is sometimes what you get. This is the only pain really, is putting all these screws back in. If I was a good YouTuber, I'd do all this as a fast forward. That brings me actually, my mate Andy's just given me some more old laptops, and one of them's quite a nice, it's got an i3 processor in it, so it's better than what I'm using at the moment. I've just got to get a new keyboard for it, because the keyboard's no good. But then hopefully I might be able to sit downstairs and actually do a little bit more editing on some of these videos. Because since my Dell died, I've literally not been able to do very much. In fact, I've still got the hard drive out of my Dell, so I'd probably just stick that in it. Get it to configure. Right. Well, they definitely went to town with the screws on this. You can't say that they were stingy with the number of screws that they used. In fact, if you just imagine this to a keyboard made even a few years later, you'd have probably had a load of plastic clips, and you might have, if you were lucky, had a couple of screws. Or if you were really unlucky, everything's bonded together, and you've got they basically put the back on with these plastic tabs that stick up and then melt the end of the plastic tabs. So some keyboards were made, and then obviously if you need to get in them, the only thing you can do is cut the plastic tabs off to gain access, and then somehow stick it back together. Or as I've done in the past, then I've took tiny screws like this that I've salvaged out of a scrap keyboard, and took my PCB drill and actually drilled through the little plastic tabs, and replaced them with a plastic screw like that. I've had to do that on a few keyboards that I've worked on in the past. We've got that one under there. It's trying to spot the last few screw holes now. It's easy when there's all, but I'm down. Ah, there it is, and I've got one last screw. Well spotted. There it is. Okay, shall we see if it's going to work? Hopefully that's fixed the A key. I can't see it being any more than that, because it really was just a case of it was a little bit on the mucky side on that A key, but everything else looked absolutely fine. Right, let's put that in there. That slot's in its slot, and we push that down like that to lock it in place. Sit the keyboard down, put the two screws back in, And we'll connect the screen back up, and we'll see how it behaves. Right, there we go. That's all back together. We'll put the screen back on. And if this works, then we'll put the case back together. Right. Let's plug some power back into it. Although the main battery should be charged now, because I've left it plenty of time charging. Right, there we go. Switch on. Let it do its memory test. Can you see that alright? Yeah, I think you can see that okay. It's very difficult to know really. Right, anyway, there we go. Let's try A. Look at A now. Perfect. Yeah. Just make sure all the rest of the keys work. Yeah. So it just needed that tiny little bit of a clean. Yeah, they all work. Brilliant. So let's get you zoom back out. So let's switch off. I think we can put this computer back together. Right, let's put the keyboard down. Now I think the trick to this is to get this back bit there clipped in first, and then get the front bit clipped in. There we go, that's clipped in. There's a clip on one of these sides here that you've got to kind of like fish in. That one, that's clipped in. Lovely. That seems to have gone together really nicely. Right, let's get the screws in it. Notice it's still a little bit grubby on the bottom. I might have to get the old cleaner out again and just have a go over the bottom. I didn't realise how it was a little bit dirty down there actually. And then we might even see if it's going to boot off its battery. See if there's enough charge in that battery now. Should be. There we go, that's all the screws in. Move my coffee out of the way. Move these bags of capacitors out of the way. Okay, there we go. Open it up. I've not got the power on, so this is see, it'll switch on battery. And the lights turn green, which means it's got a charge in it. There we go, it's booted up. Let's just apparently there's a drive D. The drive D apparently is the RAM drive, so let's see. No, oh, perhaps not on this. Oh, I think I need to run something as a configuration disk or something, because I had it all disconnected. I'm pretty certain from what I was reading that there's the RAM drive is a D drive. Because this has got basically this has got the RAM expansion. It's a 700 and something K RAM expansion installed, which take 128K of that basically takes your original 512K base memory up to 640K. So it's like a standard your maximum you can get on a standard XT. The rest of that RAM, the other 512K of that RAM, is a solid state RAM drive, so it's basically like a bit like an SSD. It's a small hard drive. It's a small half megabyte hard drive basically that's based in battery backed up RAM. but I don't think that's configured at the moment, probably because, like I said, I had it all apart. I had that board off it and everything. I think it's lost all its configuration settings, but we can look at that anyway. That's not a major issue. The thing is, we've actually got the computer back together and working. We can load software on it. Let's put a disk in. I had got it working, so A drive now does work. There we go. Let's have a look at Dig Dug. We'll have a look at Dig Dug on this screen, shall we? Just for a little laugh. It should be able to run it, because I mean it is a. Oh, hang on. Spelt that wrong. Dig, and it should be one of them, not one of them. There we go. There we go. So it's Dig dash Dug. Oh. Oh. On that one, it's the other way. It's then under. Let's see if it'll load this time. There we go. Let me just get that out of the way, because I just noticed that cable's in shot of the screen, isn't it? Let's get that out of the way. There we go. Dig Dug. Press any key to start. I'll zoom you in, see if you can see this anyway. Sorry you're at a bit of an angle, but it's really the only place I can put the camera. Press any key. Do you want full colour? Shall we have full colour? Yes. Do you have a joystick? No. Please hit the key you want to go up. We'll have up, down, left, right, space to jump, and we'll have just me playing. Well, actually, it's really is better than I was expecting. I'm dead. It is more playable than I thought it really would be. Got to admit. Anyway, let's get off that. What I thought we'd do as a final bit of this video, let's and that was running off battery then, so battery is a success. What I thought we'd do as a final bit of this video is have a look at the original power supply. This is the proper Toshiba power supply that came with the laptop. It is the original T1000 supply, and as we said when we first got it, it was dead. I mean, the guy that I bought the laptop off had said it was dead, so let's see if we can find out what's wrong with it, 'cause it would be nice to get it working and be able to have the original supply with it. Let's check the obvious first. We'll check the fuse. I don't think we've done that yet. So let's get the meter out. Let's have a check on the fuse. The fuse is good. So basically we're going to just go through this. We'll do some basic fault finding on this power supply and see if we can find out why it's failed. So let's get inside it. Oh, and that's fun straight away. They seem to have, they've actually glued over the top of the screws to stop you getting the screws out. I think we can deal with that though. Where's my thing to deal with that? There. Let's get the spike in there. See if we can get some of this crud out from inside the screws, and then hopefully we can get them out. The real worry actually is that we get this out and find out that the actual transformer inside has been potted in resin, in which case no, there's nothing we can really do with it. But hopefully they've just done this as a bit of an extra, like, security or safety measure to stop prying screwdrivers and all that, but it's not going to stop us, is it? Straight round it. really just a case of getting the glue or whatever they've used. I think it's probably glue out of the centre of the screws, and we should then be able to get a screwdriver in there and see if they're going to come out. Let's try that screwdriver. Yeah. That's first screw out. That's the next screw out. And that's the final screw out. Right, let's see what we've got. And we're not encased in stuff, that's good. Right, let's see if we can get this out of the... Right, the first thing we're going to do is some basic continuity tests. So what we're going to do is we're going to check from the live pin there to where the live is on the board there, and from the neutral pin there to where the neutral is on the board there. That'll just ascertain that the mains cable's okay. We're then going to do exactly the same thing with the DC side of it. So we'll check from the centre pin there to the other end of that, and we'll check from the outer case of that to the other end of that, and that'll just ascertain that the cable's actually good. I mean, that could be our problem. We could have a bad cable. I do actually notice it does look a little bit manky there. So we may just be a case of just shortening this cable slightly, and we can take it from there. But first things first, let's just check from the live side of the plug, that side of the plug there, to the live wire, which is there. Yeah, and we've got continuity there. And we'll try from the neutral side of the plug to there, and yes, we've got continuity there, that's fine. Now we'll check from the centre of the DC jack there. Let's just make sure, double sure where the wires come in. Right, so one connection is there, that's the positive, and the other one is, where's the other wire going? To ground, which is that one there. So we've got positive there and we've got ground there. We know this is centre positive, so that should be positive on that side there. So let's try that. And we get absolutely nothing. Nope, we've got nothing there. So let's try, just double check it's not over there. Nope. We'll try from the outer, basically the outer of the barrel to this side here, which should be ground. And indeed it is. We've got continuity there. Yeah, we've got continuity there, but we don't have continuity between the centre of the barrel and that side of that capacitor, which should be the positive. That's the output. I bet you £1 to a penny where it joins there, where it looks a little bit gnarled and a little bit broken. That's where our problem is. So just to test that, where's my snips gone? Oh, these will do. Actually, no, where have my snips gone? I'll use these ones. We'll cut that there. It's already damaged there anyway. We'll have a look at the rest of the cable, make sure there's no damage on it. Let's get the iron warming up. We'll need that. Well, the rest of the cable looks alright. It doesn't look to be, it looks a little bit twisted up, but that's not a problem. We can straighten that. But there's no tears or kinks or any obvious damage on it, apart from where it was at that end. So we'll take a couple of inches off just to be on the safe side, like that. And then we want to get this wiring out of the transformer. That's not good. As I lifted that, oh, I think I can fix it. literally as I just touched the board then, the board's broken away from the transformer there, and it's actually just snapped the wires. That's on the primary side as well, that's on the main side. It's actually just snapped the two tiny little filament wires off. That's really bad design. Because I mean, I weren't flexing it much then, I was literally just pulling that so I could get the cables round to desolder them. And that's broken free. That's really crappy. Can you see that there? Look, that's actually... And that's not the pins coming out of the board, the pins have actually broken away from the transformer. And like I said, that's allowed the mains wires there to actually snap off. That's no good at all. The one on that final pin. Is that a feedback or something on that final pin? Yes, it is. So 3 of them have broken off. Thought it was just 2 then. This might be curtains for this. Let's see if we can get them back. I can't even get in and get that one. I have a horrible feeling it might be curtains for this transformer. That's not good. I thought it was going to have a simple fix then, you know. We definitely had a break there, but we can solder that one back there. We could solder that one back there, but there's a third one here that's broken off. That just seems to have disappeared. And it's got a component across it, it's got a capacitor across it, so it's probably actually needed. I wouldn't understand why on a... what's connected to it? Yeah, it's the mains input. It's the live input. The other side there is your neutral. That's not good at all. What I think we'll have to do, we'll have to desolder this board off here and see if there's anything we can do with that. And so my other option is take one of them modern transformers and mount it in here and just do away with this thing. At least it would look period correct. In fact, I'm tempted to do that, because that, even if I repair that, I'm not going to be happy with it. I'd have to put a new transformer. Let's get this transformer off and have a look. Even that's pulled out. I've got the pin out. Right, let me show you what I mean. You see these pins? They should be actually fixed properly down into the transformer, and they just broke free. I don't know what's happened there. I've never come across that before, where the transformer's literally just pulled apart off the... I wonder if this thing's been dropped. What if this thing's been dropped and it got whacked down like that, and the actual weight of the transformer inside it has pulled it away, and that's what's actually broken them free. So we've got a transformer with literally with multiple faults here now. No, there isn't another wire on there. I was mistaken. It is just 2. It is just that one there and that one there. They're the mains input. Well, in fact, we can find that out, because we can check continuity between them with the meter and see if we've got continuity between them 2 wires. That one there. And get on there. And that one there. And yes, we do have continuity, so the winding's fine. But do I want to reuse that transformer? I mean, I don't like that. The fact that even that one's loose. They're all loose. Do we do away with this transformer and rebuild it with that modern switch mode inside this case? And you know what? I've got a few of these transformers, these modern ones. They are cheap Chinese junk, but I think what I'm going to do is I'm actually going to, yeah, I'm not going to reuse that. If it hadn't got that physical damage on it like that and pulled them pins out, I'd have just cut that lead. I'd have basically done what I was going to show you. I was going to desolder them 2 wires there, take that grommet off, put that grommet back on the old cable here, and re-terminate it, and we'd probably be good. In fact, dear me, it's definitely had a look at that. You can see that capacitor there. Look at the dent in it. This thing's been dropped. So that's probably, even if we had just repaired that that fault, it wouldn't have worked. It had already broken off them 2 mains wires, I think, when it had been dropped. So yeah, I'm going to call it scrap. I really am. And we're going to take this cheap Chinese plasticky transformer I've got here, and we just need to get inside it. There we go. A couple of swift blows with basically just held it on my knee, handle of a screwdriver, and just give it a few cracks like that, and that's usually all you need to get inside these cheap plasticky Chinese transformers. We're in. Look at that. Everything we need there. It is pretty cheap, you know, generic cheap Chinese, but it really doesn't matter. Let's desolder these wires. I'll put that in my junk box, because you never know when that'll come in handy for something. There's plenty of room in there for that. What we will do, in fact, I wonder, no, let's just get rid of it. What we'll do, desolder the wires off this. That's live. It's neutral. I'd say we'll keep that, but no, that can go in the bin, I think. We might as well use this cable, since it's actually in much nicer condition, and in the connector's right, it fits perfectly. So we will reuse that. DC connector. We'll remove these 2 wires here. That's interesting. These have, I don't believe this, these have been repurposed. You've just seen me remove this from that power supply, and I have literally bought dozens of them power supplies in the past, because I tend to convert them for use with ZX Spectrums. I put a little inline switch in the cable, and I use that to reverse the polarity on them, because they're as I buy them, they're centre pin positive, and obviously for a ZX Spectrum you want centre pin negative. So what I do is I put a little switch in the actual cable on them, put a little switch in there, and I use the switch to reverse the polarity. You know, obviously I cut the wires and I swip them round inside when I add the switch, and I use them for a lot of ZX Spectrums. I've never actually cracked the inside of one of these open, and I think these things are salvage. Have you look in here now? Can I show you? And this is just how I've removed it out of the thing. Can you see them 2 wires that are cut off there? Can you see them? And then also this potting, which doesn't seem to really match anything in the case. And can you see these? There's a wire there and a wire there, actually cut off. And they're the mains input there. And then they've tacked on the bottom 2 new mains wires there. And that's the output there. And they've actually just tacked on from off that capacitor there the output. That is snide. Oh, good old China. Never let anything go to waste, eh? So I wonder what these were originally for. They're not horrendously built, actually. You've got good separation there between the main side and the low voltage side. You know, plenty of separation. They are fused. They've got decent caps in them. Well, they're not decent quality, but they're decently rated. And that's... Well, you find something new every day, don't you? Well, we're going to use it anyway, sod it. It'll do the job, so we'll assume red's live and the black would be neutral. That's our old colour code anyway, we'll stick with that. Let's get these old wires off and we'll do as they did. Let's get that off there. Get that off there. Okay. Yeah, that's definitely our input, because that'll then go through that input fuse. Let's just see if we can get this bit of wire out of the way. There we go. I suppose if we pull off that that bit of sealant there, we can actually get to the other one as well and get that out of the way. Well, this is, I said, I was not expecting anything like this. Come on, get that out of the way, and then we can. Yeah. There we go, that's better. You don't need that horrible stuff around there. We can see a bit. We can see a bit better now. We'll get that out of the way, and that gives us somewhere better to connect the inputs. There we go. Right, where's our piece of cable? Let's see if we can get this into there. I think I might have to just slightly drill them holes out just to clear them up, and then I think that would go in there. There we are. Turn that off there. Oops. There we go. That should work now. Let's try and get them back in. That goes in lovely now. We'll solder that one in place. Where's my solder gun? There it is. First one in. Let's do the same with the neutral. a little bit tighter. Oh, it just keeps dropping out the hole. I'll just push it in, and I'll just touch it on the other side with the iron just to bring it through. There we go. Has that got it? Yeah, there we go. That's nice and attached. It's alive, nice and attached. If you look there, I'm going to reuse the original output cable from the cheap Chinese supply because it's the right connector. There we go. So obviously it's not going to weigh anywhere near what the old supply weighed, but it will look right. Going that way. Ah, there we go. I had the grommet in there slightly wrong then. Actually, it fits. Believe it or not, it fits in there. Perfect. Put the case back on. There we go. And we'll screw that back down. Yeah, screw that back down. Bit of a pain with that bit of glue on them screws, but hopefully no one will have to go in this again. At least not for some time. Tickles me that though, because I mean those. It's not as though it's just like a one-off thing. Going, them power supplies, they sell loads and loads and loads of them. So I mean, you saw that they blatantly they've reused a board that they've salvaged from something. What have I done with that third screw now? The bloody hell has that gone? I've not moved from here, have I? Oh hell. I may have to find a substitute screw for that, because it seems to have gone AWOL. It's not on my floor. Where the bloody hell's that gone? Have we got anything that's suitable in here? Yeah. Fortunately, that's one reason when I scrap stuff, I keep I always keep the screws. In fact, that looks better anyway. Should I change the other? Should I change the other ones for? Should I change the other ones for new ones as well? Make it all look the same. Should do really, shouldn't it? Because they wouldn't have that horrible, nasty plastic on them then. Seeing as I've got them, we'll put new screws in it. And the old ones are silver and these ones are black, but I don't think that matters. They do still look a little bit on the better side than them horrible plasticky ones. There we go. So we have a new power supply now for the Toshiba laptop. We'll just give it a quick test. We'll just test to make sure that the voltage is right coming out of it. It's switched on. Let's get the old meter and set it to volts. We should have just about 9 or 10 volts coming out of this. 9.8 volts, that's absolutely spot on, that. Perfect. Remember, that's off load. Let's plug it into the old laptop. Let's give it a switch on. Laptop is working. So that's the laptop fixed. That's the power supply rebuilt. Not quite the way I was initially anticipating doing it, but never mind on that. We have a nice functioning vintage laptop. I'm absolutely super pleased with this thing. This isn't going to be. I'll leave this. This is the end of the little repair series. But you will definitely be seeing this laptop again. I have some plans to actually use it. Like I say, I'm hoping I can use it with my ICE component analyzer. It's just the right age and the right piece of kit to actually use with that. I mean, it is perfect for it. So you'll see it then, and hopefully if I can figure out how to upgrade the RAM in it to I can upgrade the ROM in it to MS-DOS 5. I think we'll do a little video on that. So I'm going to leave it there for now. I hope you enjoyed this update on the project, and see we've actually got it fully working now. I still haven't actually. I'll just have to double check about booting from a DOS floppy disk, but I'm not too worried about that. It boots to 11 at the moment. It runs all the software I want, so I'm happy with that. But yeah, we will be seeing this computer in the future, so hope you enjoyed that. Thanks for watching, and goodbye.